Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 127 word ladder. This is a hard level difficulty problem. We're told that we're given a transformation sequence from word called beginning word to word end word using a dictionary word list, which is a sequence of words such that every adjacent pair of words differs by a single character. And given two words, we need to find the number of words in the shortest transformation sequence. So we need to find a sequence that we can transform the word from the beginning word to the ending word. So in this example, there are 5 transformations because we go from hit to hot, from hot to dot, from dot to dog, and from dog to cog. So these are 5. The length of the number of transformations we do is 5, so we return 5. So if it doesn't already make sense, or if you still haven't got it, this is basically a graph problem where the beginning node is the beginning word and the end node is the cog, is the end word, and all the nodes in between are also part of the graph. And we need to find how many, how many edges we need to get to go from the beginning word to the end word. So how do we solve this problem? Well, it's not going to be a depth first search function solution, but it will be a breadth first search solution. So we're going to use a queue data structure to basically find the number of edges it takes to get from our beginning word to our end word. But before we do that, as with any hard problem, there's another step we need to do, and that's to find all the different permutations of the word, so the different patterns. So for example, we've got hit. So there's 3 patterns in hit. There's HI, there is HT, and there is IT. So these are 3 different patterns for our transformation sequence. So what we need to do to create our graph or our adjacency list is take each pattern and create the permutation and map each word to the correct pattern. And it'll make more sense as we actually get coding up. So let's do that. Let's actually do phase 1, which is going to be creating our pattern map. So our pattern map is going to be equal to a Python dictionary. And we're going to say for each word in word list, we're going through each word in the word list. And we want to say, actually, first let's get the word length. So the word length, remember, all words are going to be exactly the same in this problem according to the constraints. So the word length is going to be length of the first word in our word list, or actually word list 0. So for each word in the word list, oh no, actually we could have an empty word list. So let's instead say begin word. Okay. So for each word in the word list, let's say for I in range of word length, let's create our pattern. So our pattern is going to be equal to basically the word and a star like we did before. So let's say new p is going to be equal to word, everything from the beginning to I, plus a asterisk plus a star, and then plus everything from excluding the word, the letter at the start, so I plus 1 till the end. So that's our pattern. And now we want to add our pattern to our pattern map. So we're going to say if new p is in our pattern map, we'll say new pattern map new p dot append, and we're going to append this word. Otherwise, we're going to just create a new list. So we will say pattern map new p is going to be equal to an empty list, which takes in a word. So that's our word list done. Our pattern list done. And now to do the breadth first search, should I say. So we want to get a queue. We've got an empty queue here. And we want to put in our queue our first word. But we don't actually want to put the first word. We want to put 2 elements. We want a 2-dimensional list. So we want to put our beginning word, and we want to put the initial depth, which is going to be 1. or the number of edges it basically takes to get from the beginning word to the end word. And we want to also create a visited set, because what we don't want is to come across the same word multiple times. So we want to just say visited, and we're going to set that equal to a set. And what we want to do next is actually say while the queue is not empty, let's get the word and the length from queue.pop 0, because we want to pop from the beginning as a queue data structure should pop. And we're going to add to our visited data, what's the word I'm looking for? Data structure. We want to add our word. And now we want to create patterns for each, for the word, so that we can then append those patterns or those other words to our breadth first search queue. So we want to say, I'm going to say for I in range word length, and then I'm going to do the same thing actually here. We're going to say new pattern is going to be equal to pattern of the current word. And we want to say for each pattern in the pattern map. So for each pattern in pattern map, let's check that word, that the new word that we have is, or for each word in our pattern map, we want to check if that word is equal to the n word. If it is, then we return the length. Otherwise, we append to our queue. So actually, this is wrong. We should put if new p is in the pattern map, and then for each word. So for each word in pattern map and pattern new p. So for each word in our pattern map, or actually we already use words, so I want to say for each word too, let's just say. What we want to do now is say if that word is the n word, so if word 2 is equal to end word, then we're just going to return the length plus 1. Otherwise, we want to add this word to our queue. So first of all, we're going to check if word 2 not in visited. So if this word is not in the visited queue, word 2 not in visited queue, queue.append, we want to append two things. We want to append word 2 as well as length plus 1. Boom, there we go. So what happens if we don't find a sequence? So there is no sequence of words from beginning word to end word with any transformations. Well, then we just return 0 if no such sequence exists. So we're going to return 0 by default. Now let's run the code. Let's check that this code actually works. And we pass both test cases. So let's check our submission actually works, passes all the test cases, and it does. So in terms of time complexity, guys, we're looking at an O of L times by N time complexity, where L is the number of patterns, the number of permutations, and N is the number of words. And that's going to be for both the space and time complexities. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.